Hello students, this is part 1 of the video lectures for section 5.4, Factoring by Grouping and Special Forms. In this video lecture, our objective will be able to factor the greatest common monomial factors from polynomials. So let's get started. In example 1, the question asks us to find the greatest common factor of the following terms. In order to find the greatest common factor of terms, what we want to do is take what's called a prime factorization. So we want to take this 6x to the fifth and we want to write it such that it's only prime factors being multiplied together. So to write 6 as a product of prime factors, we need to write 6 as 2 times 3. And then since we have x to the fifth, we want to write 5 x's. So 18x to the fourth. We can write 18 as 2 times 9. And 9 we want to write as 3 times 3. And so we have 4 x's, so I'm going to write times x times x times x times x. 24x to the third. I want to write 24 as 2 times 12. 12 can be written as 2 times 6. And 6 can be written as 2 times 3. And then we want to have the 3 x's. Now at this point we want to circle the things that we have in common. So we can see here each of them has a 2. Each of them has a 3. And each of them has 3 x's. So we have 1 x, we have a second x in each, and finally we have a third x in each one. So finding the greatest common factor, we write a prime factorization of each of the terms, and then circle the parts of the term that are included in each of the 3 terms. Once we know which ones are in common, we multiply them together. So our greatest common factor, or GCF, is going to be 2 times 3 times x times x times x. And 2 times 3 is 6, and we have x to the third. So our greatest common factor here is 6x to the third power. So our greatest common monomial factor is defined in this way. If a polynomial in x, meaning x is the variable term, has integer coefficients, then the greatest common monomial factor of the form ax to the n must meet the following 2 statements. The coefficient of a must be the greatest integer that divides each of the coefficients in the polynomial, and the variable factor x to the n is the highest powered variable that is common to all terms of the polynomial. So back to our previous example, you can see our greatest common factor has an integer component of 6. And in this case, we can see 6 divides 6x to the fifth, 18x to the fourth, and 24x to the third. The variable component, the x to the third, can be taken out of x to the third, x to the fourth, and x to the fifth. So that confirms our answer is in fact 6x to the third. So if we want to factor out the greatest common monomial factor from the below expression, first we need to figure out what the greatest common factor or greatest common monomial factor is in this case. So we have 6x to the fifth, which we know from previous examples is 2 times 3 times x times x times x times x times x. We have 24x to the fourth, which can be written as 2 times 12. 12 we'll write as 2 times 6, and 6 we'll write as 2 times 3, and then we need 4 x's. And 12x squared we can write as 2 times 6, which is 2 times 3 times x times x. Now we can see each of these has a 2, each of these has 1, 3, and each of them has 2 x's. So our greatest common monomial factor is going to be 6 times x squared. So when we factor out this GCF, we want to write this as 6x squared times some remaining polynomial. Now the signs of our polynomial are going to stay the same, so we want to go ahead and add in the 2 plus signs. So what gets filled in each of the blanks is the remaining pieces from each of the factors. So in this case, we have x times x times x, and that uses all of the pieces. So x times x times x gives us x to the third left over from the first part. In the second term, we have 2 times 2, which is 4, times x, so this is going to be 4x squared. And the remaining piece from the final term is just 2. So the answer in this case, factoring out the greatest common monomial factor, we take the 6x squared out, and so we have 6x squared times the polynomial x to the third plus 4x squared plus 2. Sometimes you'll see that questions start with a negative. So in this case, we have negative 5x squared plus 10x minus 20. The first way, because you can see here it says to do this in 2 ways, the first way is to immediately remove the negative. So the first way says write this as negative and then 5x squared positive minus 10x, and so we change all of the signs inside the parentheses because we've already taken the negative out. Then we can see that there is no variable term that we can pull out of this, but each of these terms shares a 5. So we could pull out a negative 5 and write this as x squared minus 2x plus 4. So that's the first way to do it. The second way says don't worry about the negative at all. Just factor out the 5 and leave it as negative x squared plus 2x minus 4. So when you see that negative in front, realize there are potentially 2 ways to factor the polynomial. You could bring the negative out, or you could leave the negative inside. My preference is to take the negative out. That gives us a leading coefficient of our polynomial that's positive. And that concludes this video lecture, the first part of 5.4.